So apart from nylon, and this is not in your textbook, but I just want you guys to hear it out because polyester is such a big thing. Polyester is another copolymer. It's used in our clothes and used in our, as a clothing fabric, and probably it is the most popular clothing fabric. Again, you just combine the monomers and you would get the polyester molecule. And I'll show you how that happens. It's called polyester because it's many esters, and you'll see that now. So have a look there. Terephthalic acid and ethylene glycol. And what I need you to notice here is that the OH from here and the H from here are eliminated, and you get this ester group. That is why it is called polyester. In the whole polymer chain, there are many ester groups which are repeated, and these are the ester groups that are repeated, and hence it's called polyester. Very, very popular clothing material. And if you go to Target, Kmart, and check out what the fabric is made up of, you'll mostly find it's polyester. Actually, there's a movie called Polyester, and again, it's because polyester fibers are drip and dry. Basically, they quick dry. The quick dry things that you wear, especially for things like track pants and those Adidas striped pants that people use for wear for jogging. You would have noticed if you wash them and they dry really quickly, they're made up of polyester. They are really uncomfortable, but they dry really quickly. Okay, now I have already given you a very brief overview of condensation polymerization. If you just got that I have to combine the two molecules and eliminate water, I'm happy with that. Addition polymerization does not require elimination of water. On the contrary, it's just combining two monomers. All you need is double bonds, and those double bonds, when two monomers which have double bonds are in the presence of each other, there's a shift in the electrons, and that shift in the electrons creates that attraction, and then you get a long chain because of that double bond. So I'll show you a chemical reaction which will explain it better. Again, addition polymerization is used in the manufacture of PE or polyethylene, and polyethylene is everywhere. Monica has a plastic bottle there which uses most probably, which company is that? I think that's low density polyethylene, and you'll know that if you put boiling hot water in it, it will lose its shape. That is high density polyethylene. No, that's metal. No, that's metal. Some plastic bottles are high density polyethylene, and that means that they can take in really hot liquids. A lot of the blenders, if you've heard of Vitamix, Breville, they make they make their blender jugs out of high density polyethylene, because you can even make soups in those blenders, and when it gets so hot, if you use low density polyethylene or medium density polyethylene, you can't, they'll basically melt, or they'll lose their shape. So when you think of high density polyethylene, then you're thinking about water bottles, your trash bins. That is high density polyethylene. The dustbin that we have there, the synthetic lumber, toys, buckets, whatever. Some plastic benches that you'll find in the park. Now, how does that work? You need a double bonded hydrocarbon. Oh, do we know about a double bonded hydrocarbon? The simplest one is ethene, and hence the name polyethylene. Many ethene molecules, when they combine together, give you polyethylene. Polyethylene is that's polyethylene on the garbage bag. But we have always associated polyethylene with just being a plastic bag or a garbage bag, but turns out polyethylene, high density or low density, will cover up basically everything, every plastic that you can think of in this room or generally in the grocery store. It covers up basically everything. and it's cheap, and that's why it's out there. The good thing about it is that you can mold it into any shape you want. The bad thing is it does not degrade, so you're stuck with it. You have to recycle it because it's so stable and you can't just get rid of it. And if you try to by incineration, it will create such harmful gases that they're carcinogenic, they're cancerous. I did a project back in my university in India, uh, which was the use of reinforced fiber glass in cement, in concrete. And that reinforced fiberglass is used to strengthen a lot of building structures. For instance, airplanes, they use a lot of glass reinforced fiber plastic in their structure, in the body of the airplane, because you want to give it that strength without adding too much weight. It's an aluminum body. We have really light bodies for the airplanes so that they can fly off, but you still want to add something that strengthens the structure of it, and they use a lot of glass fiber reinforced plastic. Problem is, yes, you can use it, but when you're making it, when you're making the structure of the airplane, you're adding, you're making the structure of the glass fiber reinforced polymers, which will fit into the airplane. Uh, they're custom made, so we mold that structure, and in that process, you lose a lot of GFRP in the form of waste powder, which is it just has to be somehow eliminated because you can't use it in anything else. That's just waste powder. And the problem is that waste powder is found to be carcinogenic. You can't put it in the ground. Uh, you can, but it's the same thing. When you're putting it in the ground, still a lot of it is released to the atmosphere. You can't burn it because it has chlorine, and it will cause it releases chlorine gas, which combines with water to form HCl, and you don't want that acid rain and all that. You don't want that as well. So what we did was we used this polymer material and we actually uh, mixed it with, in my project, in my professor's project, we mixed it with concrete in a concrete mix, and we found that it actually increases the strength of the concrete. And by doing that, we were able to get get a company to create slabs of. So you see these concrete slabs that are out there, floor pavements. We convinced them to mix the glass fiber reinforced polymers into the cement, into the concrete mix to get stronger concrete slabs. In that way, we were reusing that fiber material, but and we were substituting it for sand, so that saved in the use of sand 15%. We substituted 15%. That removed the 15% sand from it. As a result, we had 15% substituted concrete slabs, which were cheaper and stronger. And that way, we saved sand and we used GFRP. This was a project that I did for UAE. Suddenly, got reminded after we started talking about polymers. Oh, that means I have done polymers. I just forgot about it. So, there's a lot that you can do actually. And polymer science by itself is a field of work. You can do so much in it. So, ethene, when it combines together with itself, will result in polyethylene. A reaction. So, all you need is it's a chain reaction, and I'm sure that Mr. Garrett has given you so many examples of chain reactions. An ethene molecule combines with an ethene molecule, and in that process, the bond shifts here. So this bond shifts here, this bond shifts here, and that the continuous shifting of the bonds to the next carbon results in polyethylene. So what does that look like? Something like this. So it's a really long, structured arrangement of ethene molecules. And if I could just, yeah, I probably do it here. You have C, that's ethene, that's another ethene molecule. So what happens is that double bond moves such that this double bond is responsible for the bond between carbon and carbon. So you get C, C, and that double bond moves again, so that this is responsible for the bond between the next carbon. And you can see how this is going to go about. And it keeps going on. And it keeps going on for millions and millions of monomers keep repeating themselves, and we get a polymer. Now, if it is really structured like that, it's called high density polyethylene. If somehow in that process of combining the monomers, you get some side chains. You know what side chains are, right? Like that. If you get some side chains, that results in low density polyethylene. Now I want you to discuss, do a think pair share, and tell me why is it that when we have branched chains, you'll get low density polyethylenes. What characteristic changes? So think about that. So like this says, when the chains are 500,000 carbons long, when the chain gets really long, then we are talking about things like bulletproof vests. We use it because they can withstand the impulses that you get from bullets. Joints. You put plastic joints when your joints wear off, your natural joints wear off, and that's again high density polyethylene. Actually, these are called ultra high density polyethylene, if I'm not wrong, because it goes up to 500,000. Let's look at another one. So we've talked about high density polyethylene. This is low density polyethylene again. You see the chains, the branched chains. They result in really weak polymers, but they do have an advantage. They're flexible. Try stretching that Woolworths or Coles bag. It does stretch, and if you get a nice strong plastic one, you'll find that it's stiff. So high density polyethylenes, because they're high density, they're stiff. Low density are flexible. There's an advantage as well to it. PVC, polyvinyl chloride, again a high density polymer. It's used in pipes. So all these pipes that we have, if you open the cabinets there, they're high density polyethylenes. They're good, and they're not polyethylenes, high density polymers. They're good until you, Tyler, should I say it? They're good until you burn them. If you burn them, what happens is they have chlorine molecule in them, and if you burn them, that gives rise to hydrochloric acid gas. And as soon as you ingest that gas, it goes into your lungs, collects the moisture from the gas, collects the moisture from your lungs, and turns to hydrochloric acid. And that way you can actually ingest hydrochloric acid, and that causes suffocation, sometimes death, if you're burning a lot of PVC, polyvinyl chloride. So that's why I didn't want to say this in front of Tyler, but okay. Now, low density polyethylene used in these kind of materials, even those bottles that you get for storing your mustard and all, they're also low density polyethylene. PVC, I was just talking about PVC. It's pretty much the same as polyethylene, but look, PVC just has different monomers. Polyethylene has ethene as a monomer, PVC has ethyl chloride as a monomer, if I'm not wrong. So it's the same kind of process. So just to reiterate what I was talking about, PVC pipes, you might have seen these. You burn them, that results in HCl, which combines with the moisture in our lungs to get hydrochloric acid. You don't want that to happen. Now, we are ready for question 2 and 6 from set 20. So I'll give you another 5 minutes, I think. And then I really want to go into the recycling bit. But that's not in your course, but it's important.